Okay, now let's look at this exercise. We have a traverse contains 5 stations A to E, given the exterior angle, meaning that the work was conducted clockwise. Okay, first let's check the angles. Okay, we're going to sum all the angles. We're going to check that against the theoretical value. So let's do that now. So I've listed all the angles. Okay, observed angles, the mean observed angle. So that's basically observed. And I added up them together and I obtained 1,260, 0050. And by applying the formula to check the sum, that's what the value should be, 1,260, 0000, which means that we are more than 50 seconds than the actual sum, okay, the theoretical sum. So we know that we have 5 angles or 5 stations, so error is positive, so correction will be negative. So divide that by number of angles. So our corrections per angle is minus 10 seconds. We're going to do that there. Calculate the final angle. And if we sum all that, we should get 1,260 as what we've calculated for the theoretical value. So we have checked that. So that's done. Okay, so that's angular adjustment. Now let's move on to the latitude and departure correction. But before that, worth mentioning that error was 50, okay, and our limit was plus minus 0 to minutes 30 seconds, okay, which means we are well within the limits. So we can proceed to the next step to calculate or to determine the corrections to the latitude and departure. So let's look at the example again. Okay, if you look closely, you're given if that is north, okay, you're given a bearing from A to B, okay, which is 90 degrees. And in order to start the calculation, you need a back bearing somewhere. Okay, so obviously you cannot start from C. You cannot do your calculation from C because you don't know what the back bearing is. Okay, you can by assuming, but then you have to do double calculations. So I normally wouldn't do that. So we could either start at B, because we are given 90 degrees. That's A to B. So B to A would be simply a converse to that, a reverse to that, which is 270 degrees. Okay? Or I could start at A, and because I could calculate what that back bearing is based on the angle given here. Okay? The angle given there and the 90 degrees bearing from A to B. Okay, so I'm going to do it from there. Just make it a bit more interesting. Okay, if you're doing from B, then it's quite straightforward. Just use 270. Okay, let's say I'm going to do it from A. Let's see how do we go about doing that. Okay, let me just erase that for now. Okay, we have the angle 90 degrees. We have that angle 197, 10, 30. So we want that bearing, which means that we require, let me just change the color, we require that angle. Okay, so all we need to determine now is what that angle is. Okay, so it's basically 197, 1030 minus 90. So that would give us maybe a different color blue. Okay, so if I just erase that, okay, and this is what we need, that angle there, okay, which is 197.30, 10.30 minus 90, so that it will give you 107, 10.30. Okay, so we know that a complete circle, okay, a complete circle gives us 360. So we want the angle there. So it's 360 minus that little angle there, 107, 10.30. So that will give you a reading, a value of 252, 49.30. So that will be your back bearing from A to E. So bearing from A to E. So I'm going to use that in this example. Okay, as I say, you can either start from B, but I've chosen A just to show you how to calculate back bearing if you're given a forward bearing or you're given an angle and a reference bearing. Okay, you were also given that the coordinates of A as 500 meter north and 500 meter east. Okay, the next slide actually shows a calculation form or a computation sheet that you could use, that we normally use here in the school to do our bearing calculations. So what I mean is traverse calculations. We call it the latitude and departure computation form. Okay, we have agreed to start from A, back bearing to E. So that's what we'll do now. Okay, we're going to write E, back station, occupied A, forward station B. So that's the first point. Okay, then we'll be moving on to B, back A, C, and so on. So we're going to start from A, and you're going to finish the work at E. So which means that we have set up on each stations. Now, we've just calculated the back bearing, 252, 49, 40, and the corrected. So remember, we now are concerned with the corrected observed angle. We do not use your initial observed angle anymore. You got to use the corrected observed angle. It was 197, 10, 20. So to get your forward bearing, first, if you can recollect, forward bearing is given by back bearing plus left hand angle. Okay, back bearing plus left hand angle. So that will give you 90 degrees. Okay, as I say, if it's more than 360, just minus 360 to that value. Okay, now you will then move on. You move your instrument to B. Now you need the back bearing B to A. So that value there was bearing A to B. A to B. So the back bearing or the bearing B to A will just simply be the reverse of that. So it's 90 degrees, so the reverse should differ by 180. So you add 180 to that. So that is your back bearing. And you will continue in that manner. That's your corrected observed angle. That's your forward bearing, bearing B to C, 151, 29, 10. Now when you move on to C, when you're at C, B will be your back station. So you need the back bearing C to B. So this is, this is B to C. So just take the reverse of that. So it's 150. We know it differs by 180. So just add 180 to that. You'll get 331. Okay, 2910. And so on. So when you get to the end, when you get to the last number here, which is bearing E to A, and that number should differ with that number by 180 degrees, because that is from A to E. This is E to A. Okay, so the last value here is basically the reverse of your starting value up there. So that's how you put in a table of all the corrected angle and how you actually calculate the forward bearing. Okay, next, put in the distances. Okay, then you can just now start with your latitude and departure calculation. Okay, that column is for, I missed the top part though, but that column is for latitude. The second column here will be for departure. So latitude for the first one, okay, you take the distance, bearing, you get latitude 0 and 355,980 for departure, because it's practically going east, so there's no increment in the northern direction. Then you do the same for the rest of the lines, B to C, C to D, and lastly E to A. Okay, that will be your latitude and departure. So to check, you got to sum all the latitude. Okay, all this number here, you got to sum them, as well as the number for the departure. Okay, you got to sum all them, and that's what you get. 0.102 for the sum in latitude and 0.063 for the sum in departure. That's basically the total distance that you travel. We call it S. Okay, so we know in theory, we know that when you sum them up, okay, that one should be 0, that one should be 0. But it's not. Because of errors, you end up with 0.102 and 0.063. Now you've got to find out whether these two numbers here, okay, these two numbers there, are they okay? Is it acceptable as far as a second class traverse is concerned? Because we're looking at 1 in 4,000. Okay, we're looking at 1 in minimum, 1 in 4,000. Okay, put that in the space provided under here at the bottom of the page. There's a few numbers you got to fill in. Okay, so actual difference 0, and error that we've calculated 0.102 and 0.063. Okay, sorry about missing the bottom part, but it's 0.063. So put that in this formula there. When you calculate your linear mean closure using the S that we got there, it comes about 14,000. Okay, we know minimum is 4. You end up with 14, which means that you are good. Your traverse is good. You are okay. You're done with it. You're done with the fieldwork. Now you can proceed with the calculations of your final coordinates. Okay, now before you do that, you have to do your correction. So this number here, okay, that numbers there represent the Bowdish correction. Okay, total error, okay, multiply by distance divide by total distance. Okay, again, to get that value, the error, okay, I'll probably use a cursor. Okay, to get that value, okay, you use the error, multiply by the distance of that line, divide by total distance. Okay, that applies to all the corrections here. And remember, we are in error. We are more by 0.1 meter, so corrections are all negative. Okay, and we normally write them in brackets and parentheses so that we could differentiate between corrections and corrected value. Okay, and you do the same thing for departure. Okay, and you end up with those numbers. Okay, and finally, before we move on to calculating the coordinates, you got to calculate the last cell in that box, the bottom one here. That is for you to write down the final or the corrected latitude and departure. Simply that plus that, or that plus that, you write it there. Okay, so I just put it in. So those values that just appeared will be what we call, I'm going to use a different color now, what we call the final latitude and departure. So these are the values that we want, that we'll be using in the next step, okay, to calculate the coordinates of the finals of the stations in the traverse. Okay, all right. Now, I've sort of pen it to the right of the booking calculation form or computation sheet. Okay, those are the value that we just obtained. Okay, the correction and the final value of the latitude and departure. So the first thing that you got to put in is the coordinate of the first occupied station, which is 500, 500. That's given to us. Okay. Then to calculate that northing, okay, northing for the first point, which is point B after A, is basically not that northing plus latitude, that is thing plus departure. So 500 minus 0.021 will give you 499.979, and 500 plus that will give you 855,967. That is for station B, meaning that that is the coordinates of station B. Okay, to get C, you simply take that coordinate now. Okay, that coordinate now. B, we don't work from A anymore because now we are at B. So B plus that, we'll get that. Okay, so let me just use red now. Okay, so that one plus that will give you this. Similarly, that one plus that will give you that. So when you're done with it, okay, you look at the bottom of the table, you should get A. Okay, again, so A this time will be the calculated A, the computed A, the A that you've calculated, whereas the A up here is the one given to you. So you just compare, just to check whether you got any error in the calculation. The arithmetic check. We have 1 millimeter there. So if you compare to that, so we got 1 millimeter extra, and we look at the easting, we 499.999. That means we are 1 millimeter less. So we got 1 millimeter extra there. Okay, 1 extra and 1 less. So it's not a problem. 1 millimeter is practically just a rounding error. Okay, so there's no problem with your calculation, and it's good. Okay, if you get more than a few millimeters, then you know that you've done wrong somewhere. You got to check your calculation. So when that's done, we're happy with it. You will proceed your final calculations to do the cross multiplications to obtain the area of your traverse. Okay, I just put it in. Okay, we've discussed this. Just a matter of cross multiplication and taking the differences between the two rows. Okay, you sum all that, you sum all this, and you take the difference. Okay, and which is, the sum comes back to 1 million for that, and 967 for that one. If the number tends to be quite big, okay. So if your coordinates are in the order of thousands, maybe you can truncate a few numbers just to make it a bit smaller, so that we could do this calculations a bit easier, okay, dealing with smaller numbers. So anyway, continuing that, so that's what we've gotten for A and B. Just take the difference. Okay, it's modulus, doesn't matter either one, the A or A minus B or B minus, it doesn't matter, because we're just looking at the modulus. So if you do that, divide by 2, you'll end up with a value of 175.800.3 meter cube. Okay, 175,800.3 meter cube. I think it's worth mentioning that. I think just one decimal place is good enough. Okay, don't have to worry about putting more than one in there. All right, so that's basically wraps up a traverse calculation, a successful traverse calculations. You've done the field, you've done the calculation, you've done all the corrections, and come up with the final answer that we want, the coordinate as well as the contour, the area. So these numbers here, okay, the B, C, D, and E, the new established points, we know that they are established, or they were established with high accuracy, and now they can serve as control points in your future work, in your future survey. Okay, so I'm going to stop there for now for this chapter. Thank you very much, and just get in touch with me if you got any questions or if there's anything that need clarification. Okay. Assalamu alaikum and salam jahta.
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. وايساج، معا نحو مستقبل مشرق.